Now we will see this whole concept in the diagram. Here you can see the X-ray source which is incident on the sample holder. This is the place where the sample is placed, so X-rays are incident on it. When X-rays are incident on it, you can see electron pathway. Electrons are emitted, and these electrons in the form of green color you can see create a complete path, and these electrons moves toward the detector, and this detector will detect about the properties of that sample which is held under the X-ray source. So now you have cleared this topic, that cylindrical mirror analyzer, how this can work and how this can detect the electron and their properties. So simple is, when X-rays are incident on the sample, the electrons are emitted, and how electrons are emitted we see this previous in this lecture in complete detail. If you start this lecture from here, then stop this lecture and go back and start it from the start of this lecture, then you will understand the concept of CMA and also know how X-rays works and how electrons emit from the surface of core. Cylindrical mirror analyzer detector, which is used in XPS characterization technique. So how CMA works, cylindrical mirror analyzer, how this works? The CMA not only can detect the electrons from the irradiation of X-rays, it can also detect electrons from the irradiation by the electron gun. In second, the electron gun, it is located inside the CMA while the X-ray source is located on the top of the instrument. This statement can be verified in the diagram we see after another statement. The third statement is, the only electrons normally used in the spectrum from the irradiation by electron gun known as agar electron. Agar electrons are also produced by X-ray irradiation. Pass through the device called a CMA. The CMA has two connection metal cylindrical cylinders at different voltage. One of the metal cylinder will have positive voltage and the other will have zero voltage. This will create a electric field between the two cylinders. So the voltage on the CMA for XPS and agar electrons are different. Here you can see in this diagram, the upper side is zero voltage and here is the high voltage, and here upper is the zero voltage and at downward the voltage is high. So the voltage on the CMA for XPS and agar electron are different. If we see in the working of CMA, when the electron pass through the metal cylinder, they will collide with one of the cylinder or they will just pass through. So if the electron velocity is too high, it will collide with the outer cylinder. In further, if is going too slow, then will collide with the inner cylinder. So collision is possible in both ways, if the velocity is high, if the velocity is very slow. In third step, only the electron with the right velocity will go through the cylinder to reach the detector. So with a change in cylinder voltage, the acceptable kinetic energy will change, and then you can count how many electrons have that kinetic energy to reach the detector. I hope you will understand the working of CMA. In mathematical step, if we see kinetic energy, H is the constant, Planck's constant, and V is the velocity, and B is the binding energy, and phi is the work function. So kinetic energy measured in XPS spectrometer and photon energy from the X-ray source controlled and space spectrometer work function, it is a few electron volt. It gets more complicated because the material in the instrument will affect it, founded by the calibration. So these are the basic steps which are used for the calculation in XPS in the form of CMA detector. This equation will also calculate the energy needed to get an electron out from the surface of solid. Knowing kinetic energy and its photon value, velocity and work function, the binding energy can be also calculated here. To understand the relation between kinetic energy and binding energy, we see a graph. This graph is between kinetic energy of electrons and binding energy. Binding energy value is taken on x-axis and kinetic energy of electron is taken along y-axis. So binding energy from left to right, from right to left. This means that this value which is increasing, and this is the peak value. This is the first peak value, second peak value and third peak value, and move forward. This shows the binding energy and how this binding energy is increasing. And from left to right, this shows that peak, how kinetic energy is increasing or decreasing. So this is the first peak value of kinetic energy, this is the second peak value of kinetic energy, and this is the third peak value of the kinetic energy. So kinetic energy can be plotted depending upon the binding energy. So each peak represented the amount of electrons at certain energy that is characteristic of some element.